Ever wonder why a metal spoon in your soup gets scalding hot, but the air just above it only feels, kind of warm? It's a sign of this invisible force that's working all around us all the time. Today, we're diving into that force, heat transfer. Let's get right into it. Now, the answer to all this isn't magic, even though it can definitely feel like it sometimes. That scorching hot spoon, the gentle warmth of the air, and the incredible power of the sun, well, they're all just perfect examples of the 3 different ways that heat moves from one place to another. But before we can break down those 3 methods, we gotta talk about the one single, unbreakable rule that governs all of them. It's the one law that heat always, always follows. No exceptions. Okay, so get this. Heat is on a one-way street. It always flows from hot to cold, and it's always trying to find a balance. It's kind of like pouring water onto an uneven surface. It just wants to find its level. Heat does the same thing. It spreads itself out until everything reaches the exact same temperature. And that final state, that perfect balance, is called thermal equilibrium. Every single thing we're about to talk about follows this rule. All right, let's kick things off with the most direct method, the one we all kind of understand just from living our lives because we feel it every day. This is conduction, what I like to call the touch transfer. So how does this actually work? Well, if you could zoom way, way in, you'd see the particles in a hot object are just vibrating like crazy. When they physically touch a cooler object, they literally bump into its particles and pass that vibrating energy along. It's like a microscopic relay race where the baton is pure energy, passed from one particle to the very next. And that's exactly why metals are such great conductors. Their particles are packed in super tight, which makes for a really, really efficient race. And you see this everywhere, right? That heat climbing up the metal spoon from our first question, that's pure conduction, particle by particle. Your hand warming back as you hold a coffee mug? Yep, that's conduction too. The key word to remember here is direct. And honestly, understanding this is why we use things like wooden handles or plastic grips on cookware. They're insulators that are meant to break that chain and stop that little energy relay race dead in its tracks. Okay, so that's what happens when things are touching and stationary. But what happens when the particles themselves can actually move around? Well, that brings us to our second method, convection, the flow transfer. This one is all about movement, but specifically in liquids and gases. When you heat up a fluid, it expands. It becomes less dense, and it starts to rise. Then the cooler, denser fluid sinks down to take its place, it gets heated up, and the whole cycle just keeps going. This creates this powerful continuous circulation. We call it a convection current, and it basically acts like a natural heat engine, constantly turning over and spreading the warmth all around. And you see this amazing engine working at every scale imaginable. It's the rolling boil you see in a pot of pasta water, hot water rising, cool water sinking. It's how a single radiator can warm up an entire room by just circulating the air. And believe it or not, it's even what drives our weather, creating these massive convection currents like a sea breeze on a hot summer day. But here's the thing, conduction and convection, they both need stuff. They need particles to be there to work, so they can't explain the sun. For that, we need our final mode, the really mysterious one that can travel through the vast emptiness of space, radiation. Unlike the other two, radiation doesn't need to touch anything. It is pure energy, traveling as electromagnetic waves. You can think of them like light, or maybe like ripples in a pond. But here's the wild part. These waves don't need any water or air or anything at all to travel through. They can move through a perfect vacuum. This is it. This is how the sun's warmth travels millions of miles to reach us. It's why you can feel the heat of a campfire on your face, even if you're not touching the flames or standing in the hot air rising above it. That warmth you're feeling is infrared radiation, traveling directly to you at the speed of light. It's just the most efficient way to move heat across a big distance. So let's just boil it all down. The crucial difference, the big takeaway, is this. Conduction needs touch, convection needs flow, and radiation, it needs absolutely nothing at all. 3 totally different delivery methods for the exact same thing, thermal energy. So now that you know the rules and you know the players, you've got a whole new lens to see the world through. You can start spotting these processes happening all around you in pretty much everything you do. And it's actually pretty simple. Just ask yourself these 3 questions. Are things touching? That's your clue for conduction. Is a liquid or a gas flowing and circulating? That's going to be convection. And are you feeling warmth from a distance? Almost certainly, that's radiation. With this simple little checklist, you can deconstruct just about any heat-related thing you come across. So I'll leave you with a final little puzzle. The next time you make some toast, just pause for a second and look closely. In that one simple everyday act, can you spot all three modes of heat transfer at work? It's the perfect way to put your new knowledge to the test. Thanks for